Good morning. Welcome to the lesson 9-4, Transforming Quadratic Function, Day 1. The objective for today is you will be able to identify the change in the width of the parabola by comparing the graph of the function to the parent function. In other words, you will be able to look at a quadratic function and tell if the parabola is going to widen up or narrow down. So to start, we can say that the quadratic parent function is f of x is equal to x squared. And all other quadratic functions are transformations of the parent function, which is f of x is equal to x squared. Alright, you don't have to write this down, but let me explain why the parent function is f of x is equal to x squared. We all know that our standard form for a quadratic function is f of x is equal to ax squared plus bx plus c. And if a, b, and c are all real number, and a does not equal to 0, then we know that the function, the quadratic function, this function here is a quadratic function. So let's say c is 0 and b is 0. If they're both are 0, then we're left with just ax squared. Alright, and since a cannot equal to 0, the first value a will have to be 1. That's why 1x squared will be our parent function. It will be our beginning function. So in this lesson, we're going to be talking about the width of the parabola. So every parabola or every quadratic function that we look at, we're going to see if the parabola widens up or narrows down, and we're going to compare that to the original parent function to help us understand if the parabola widens up or narrows down. Alright, so to start off, let's start off with a definition. So the graph of f of x equals ax squared is narrower than the graph of f of x is equal to ax squared if a, the absolute value, the two lines in between the a just mean absolute value. And we haven't talked much about absolute value this year, but all absolute value means any value inside the two bars here, whatever that is, it will always become positive. So for example, I'm going to do one that is greater than 1. So let's say the absolute value of a -2. It's inside the absolute value bar, that's going to become a +2. Since that is bigger than or equal to 1, it's going to be narrow. The graph is going to be narrow. Let's say we have an absolute value of +3. It's inside the absolute value, so it's going to come out as a +3. That's greater than 1, so it's going to be narrow. And it's going to be wider if absolute value a is less than 1. So for example, if we have an absolute value of like 1/2, that is going to equal to, 1/2, which is a positive 1/2, which is going to be less than 1. So if a is 1/2, this graph is going to be widen up a little bit more, and then the parent function. If this was like a negative absolute value -1/5, that's going to become a +1/5 because it's inside the absolute value bar. And since it's less than 1, it's going to be the graph is going to be wider than the parent function. Alright, so let's move to the right to the example. So let's compare the graphs of h of x equal to 1/4 x squared and g of x is equal to -2x squared with the graph of our parent function, which is x squared. Let's see if h of x get wider or if it gets smaller. If it gets narrower. And let's see if g of x gets wider or if it gets narrower. So just by the looks of it, absolute value 1/4. Since we have not evaluated the absolute value, for right now I'm just gonna put a question mark here because we don't know what the value inside there is yet. So after evaluating it, you'll get a positive 1/4, and we know that a positive 1/4 is less than 1. So that means that the graph is going to widen up, so it'll be wider. Alright, next, if our a value is a -2 or absolute value of -2, since we have not evaluated that yet, I'm going to put a question mark here. Let's do that in purple. And after evaluating the absolute value, we know that anything inside the absolute value will become positive. So we'll have a positive 2. And since positive 2 is greater or equal to 1, the graph of this one will widen up. Will be more narrow. The graph that's widening up will be this outside graph right here. So that will be our graph of h of x is equal to 1/4 x squared. And the one that's narrow, we also learned that if the graph is negative, it's going to be going down. So since it's narrow and is going down, the parabola facing down will be our graph of g of x is equal to -2x squared. That means that our graph in the inside here is our parent function. Y is equal to x squared. Alright, so let's move down to some more examples. So that was an example using a graph. But let's just look at, instead of having graph, let's just say we have functions. How do you know if the function is going to be wider or narrower than the other functions? So in these three examples, I want you to be able to order the functions from the narrowest function to the widest function. And just a reminder, if we go up, if our a value is greater than 1, our function will be narrow. So narrow down here, I'm going to put down absolute value of a is greater than or equal to 1. We also know that if a is less than or equal to 1, our graph will widen up. So widen up. So if absolute value of a is less than or equal to 1, it will widen up. Alright, so I made one small mistake. Ignore the equal sign down here, I'm sorry. It's just greater than a or less than a. So up here as well, ignore this equal sign, ignore this equal sign, ignore these equal signs on the bottom. It's either just greater than or less than. That was my fault, I'm sorry. Alright, so what I would do first in example 1, by looking at these function here, f of x is 2/3 x squared, g of x is 5x squared, h of x is x squared. 1/2 x squared. So I will look at the most narrowest, which is the a value that's bigger than 1. So the only value that's bigger than 1 is 5. So I know for sure that g of x will be the most narrowest. I'm going to put that first. And then I'm going to go to my calculator and type in 2/3 and see what the decimal number is. So by doing that, I got 0.66, and that's going to repeat. And if I put 1/2 in the calculator, that is 0.5. So by doing that, I know that 0.66 is closer to 1. So that's going to be the next narrowest graph. So I'm going to put f of x next. And then lastly, our h of x will be last because that will be the most widest graph. Alright, so I encourage you to pause the video and try example 2. Alright, so hopefully you gave that a shot. Again, by looking at this, let's look at the value that is the a value that is greater than 1. The absolute value that is greater than 1. So by looking at that, 1/10 is not greater than 1. 10 is greater than 1, but 2/4 is not greater than 1. So I know that b of x will be the most narrowest graph. So b of x will be the most narrowest graph. After that, you're going to look at the other functions and see if which one is the most narrowest or widest. So again, I'm going to put these into the calculator. If you put 1/10 in the calculator, you get 0.1. And if you put 2/4 in that calculator, you get 0.5. So we know that 0.5 is closer to 1, and 0.1 is a little bit farther away from 1. So we know h of x would be the next narrow one, h of x. And lastly, z of x would be the next one. Alright, lastly, example 3. Again, pause the video, give this one a try, and then come back and check the example, your work with my work. Alright, hopefully you gave that a shot. Again, let's check the most narrowest one first. Look at the absolute value that is bigger than 1. So 1/8 is smaller than 1. -5, by looking at -5, negative is smaller than 1, but remember, we're not just looking at a here, we're looking at the absolute value of a. So the absolute value of 5 equals to positive 5, and positive 5 is bigger than 1. So we know that is greater than 1, so that would be a pretty narrow graph comparing to a parent function. And then 1/4, negative 1/4. Of course, negative is smaller than 1, but let's put that into the absolute value. Absolute value of negative 1/4 is equal to a positive 1/4, and that is still smaller than 1. Alright, so first off, we know that b of x will be the most narrowest one because it's greater than 1. And let's put these other ones in the calculator. So 1/8, if we put that in the calculator, we'll get 0.125. And if we put 1/4 in the calculator, we'll get 0.25. So by looking at 0.125 and 0.25, 0.25 is bigger and closer to 1 than 0.125. So we know that h of x will be the next graph that's narrow. And lastly, the least narrowest or the widest graph in example 3 would be j of x. Alright, so I hope this video helped you understand transformation of quadratic function, if it's going to get narrow or wider by comparing it to the parent function, and looking at the absolute value of a if it's greater than 1 or less than 1. Again, if you have any question, feel free to ask me during the work time. The homework or the assignments is on Schoology. If you need any help, let me know, and have a great day. Bye-bye.